Hello and welcome. This is a quick 5-minute introduction to Chapter 1. And also, I'm going to give a quick introduction to the introductions for this class. So let me talk a little bit about the idea of previewing a chapter before you start to more thoroughly review a chapter later. One idea you might have is doing a quick skim of a chapter. Maybe you'll watch a video like this one. You might be able to apply the ideas that we're presenting here to your other classes where maybe you don't have videos. Or maybe you just prefer reading the textbook as well. So you can always skim a chapter. What you might do is look at the section titles, look at the vocabulary words, look at some of the figures, try to understand the topics from the given chapter. One of the things you'll want to do is try to relate this material to things you may already know. Luckily, most of these classes that you might be taking your first semester here at Ohio State, or maybe for some of you this isn't your first semester, but a lot of the content you'll see in this class you've seen in other chemistry classes in the past. Just like with math, usually you don't jump in immediately to a topic you've never seen. Usually there's a few topics that you've seen before. I suspect most of the content within most of the chapters we'll cover you've seen in one flavor or another at some point throughout your education. So try to relate the things that you already know so that you can try to build upon your existing knowledge with the new things that you'll be seeing within our material. Lastly, what you may also do is review the end of chapter list of learning objectives. Every chapter within our textbook has a list of learning objectives that you'll find at the very end of the chapter, right before the list of homework problems. You'll also find a nice summary of the chapter as well within this part of the textbook. And most of your other books or your other classes probably have a similar end of chapter summary, and probably somewhere within the chapter a listing of the particular objectives within the chapter. These objectives are important because these are the ones that we primarily base our exams on. So if you're wondering what to expect for exams, it will be questions that try to capture the essence of those learning objectives. Now, once you preview a chapter, you may wonder, well, what should you do next? Well, I'd recommend you spend 5 or 10 minutes watching a video, maybe 5 or 10 minutes skimming through the chapter, and then go take a break. Go do this for something else, go do some homework for a different course that you're taking, and then at some later time come back and maybe try to do a more thorough read, or maybe then try to watch a chapter summary video. I'll have summary videos. They'll probably be about an hour long for each of the chapters. And roughly each chapter will be split across usually 2 lectures. So you may only be watching about half of that hour-long video for a particular lecture. We'll guide you along with what you should be watching or reviewing for which of the lectures as we go throughout the class. You could also try to do a deeper read. You can pause and attempt the problems that I throw into some of these chapter summary videos. You can also attempt to do the problems that you find throughout the reading if you're instead reading the textbook. Some of you guys may find a lot of value in watching a lecture video and reading, not necessarily back to back or in the same study session, but maybe you spend 30 minutes watching a lecture video, maybe you'll try to do some problems like those within the video itself, and then maybe in your next study session you'll actually do a more thorough read. Maybe you'll space these out, maybe you'll do the reading first, then come to class, then watch a video, maybe you'll prefer to do it the other way around. Some people don't like videos, some people don't like reading. Try to find whatever it is that works for you to help you learn the material as best as possible. So when working on a solution to a problem, try to talk your way through the solution. Try to develop that inner voice to help you solve problems. Much like the way I talk a problem out in class and help you solve it, those are the things I'd like you to be thinking as you're solving problems on your homework, on a test, or when you're just doing some practice. You can also read and watch through the next lecture's covered sections. So you can pay attention to what's coming up in class and kind of stay ahead of the material so you can know what's coming for a particular lecture before you get to class. Lecture itself is not going to be me just giving you definitions and ideas. It's going to be us actively solving problems, sometimes individually, sometimes in a group, sometimes you'll be watching me solve problems, but we're going to try to advance our knowledge into applying the material to problem solving. You can follow along all of the lectures and all the videos that you're watching, both in class and online. You can grab the slides like the ones from this video here, maybe pull them up on your iPad and maybe watch a video in split screen mode, or maybe you'll watch a video on some other device. I think it might be nice or easy to watch a video, say on your phone or on a laptop, and then take some notes with the PDF version of the notes open and something like Notability on your iPads. So what should you do after you review a chapter, or maybe you review the first half of a chapter? What should you do next? Well, ideally, we're going to start quizzing ourselves, ideally once a day. Now, you can quiz yourself by pulling out some of the homework problems from the textbook and giving them an attempt. You could try some of the sample and practice exercises within the textbook. I'll talk a lot about these as we go throughout the class. All those practice exercises that you'll come across in your textbook, say in the e-text, they're all answered in the back matter of the textbook, or at the very end of the printed copy of the textbook, back where you find like the answers to the odd questions. You'll find answers to all the things you may come across in the text, like the go figure problems, the give it some thought questions. These are all answered in the back of the textbook. And then one of the things you may want to do is start quizzing yourself progressively as you move through the material. So if you do a reading or watching a video, take a quiz after. If you come to lecture and you gain some new knowledge, take another quiz. Put that knowledge into use. Force your brain to pull that information back out of it will actually help reinforce the learning of that material. So quiz yourself again and again and again until you get to the point where you make the material stick. There's a textbook I'm going to talk a lot about in this class called Make It Stick. I'll put a link up to that if you want to find this textbook. If you have high ambitions of going to grad school, going to med school, of just having education be an important part of your life, I definitely make a recommendation that you find this book and you read it. I think it'll be life-changing for a lot of you guys in terms of the way you approach preparing for your courses. So the chapter 1 topics, this will kind of be the start of our quick introduction to chapter 1. Chapter 1 starts off pretty easy. I don't want this to dissuade you from the class overall is pretty challenging. Chapter 1 and most textbooks are always pretty straightforward. So let me give you a quick rundown here of the topics in Chapter 1. Obviously, we're going to talk about the definition of chemistry right away. It's the idea of the study of the composition of matter, the property of matter, and the reactions of matter. So we'll talk about atoms, molecules, and compounds, things like mixtures. We can classify mixtures as being homogeneous or heterogeneous in their nature. We can discuss the different physical properties of a substance like melting points, boiling points, densities, things of that nature. Then we get into the nature of energy, kinetic versus potential energy in the middle part of chapter 1. And we start wrapping up the chapter with a discussion of units of measure, conversion factors, dimensional analysis, and everybody's favorite topic, significant figures, and really the idea of rounding and calculations where we're dealing with experimental data. And so experimental data will be things where we say like 1.25 grams. If you add a certain amount of mass to that quantity, where do we round the final result to? So we'll have to find a way to sort of track and understand what significant figures mean, but it's really referring to an experimental quantity as being an imprecise number and not exactly what you might think of as an exact quantity. So whenever we come across a number like, say, 1.25 grams, what that number is sort of relating to, the number 1.25, is how precise we know the sort of mass of the object. It doesn't mean it's 1.25 with an infinite number of zeros afterwards. Those are not interpreted. Only 3 digits in this quantity here are actually significant. So you may have seen sig figs before. You may kind of remember them. You may forget them. But we'll talk about the rules of significant figures later. I just want us to now kind of just know that that's going to be coming up as a topic of discussion within chapter 1. So here are the learning objectives. I'm going to just zoom in on these a little bit. I'm not going to go through these and read these here today, but after we study the chapter, these are the sort of things that we'll want to be able to do. Like we'll want to be able to demonstrate the use of significant figures, scientific notation, and SI units and calculations. We want to use appropriate SI units for defined quantities and employ dimensional analysis and calculations. So these are some key objectives. We'll want to be able to make sure that we can do these things and all the other objectives that we come across within this chapter once we complete our discussions and complete all of our preparations for chapter 1. So be sure to refer to these objectives as you're studying a chapter so you know what it is you're supposed to be gaining throughout the chapter. All right, let's wrap this video up with a key problem to hopefully exemplify to us the ideas of the rules of significant figures and what they are meant to be used for in a class like this one. So let's say we measure the walls in a room to be 25 feet wide by 35 feet long. What is the circumference of the room and the area of the room expressed with proper rounding using the significant figure rules? The point of this problem isn't really to exemplify doing circumference or area problems, but just to talk about the arithmetic underlying these particular problems. I'm sure we all know that the circumference of this room would be 25 plus 25 plus 35 plus 35 feet added together. Okay, and so obviously we throw this into a calculator, we get 120 feet. Likewise, if we're doing the area, it's 25 times 35 for a total of 875 feet if you just throw that into a calculator. But the key is that this room is not exactly 25 feet wide. It's not like 25.00000 feet wide. It's like 25 with some uncertainty in that last digit. Whenever we see units given in a number, we're assuming that these are experimentally determined values. So 25 feet really means 25, like plus or minus a foot. That there is some uncertainty in that last digit. And that uncertainty is really what then tracks into our results here. So that error is going to play a pretty big role in determining the error in the arithmetic that we're doing here with these experimental quantities. And let me also tidy up that this is square feet in the 25 times 35. Now let's imagine that we have 25 plus or minus 1. So let's imagine that all these quantities are exactly as we indicate, but one of them's off. It's really 24 feet. Then it would be 119. If it's really, we're adding these all up. If it's really 26 feet, it'd be 121 feet. Our uncertainty is coming in that last digit here. So you probably won't be too surprised to learn that the general rule for uncertainty or for significant figures is that when we're adding digits, we want to look at the placeholders of all of these quantities and then round to the placeholder or extend the value to the placeholder that's of the greater value. So these all end in the exact same placeholder. So we report this value to the ones placeholder. So the ones placeholder, the first digit to the left of the decimal, is where this result should be rounded to or extended to. Now, how do we write 120 feet unambiguously to have a total of 3 significant figures? So this digit here turns out to have 3 sig figs. Notice all the values we added together have 2 significant figures each. There's 2 digits that are significant in each of these quantities, but that doesn't really matter much. How many sig figs a value has when we're adding doesn't mean anything. It's about where does the value end? They all end in the same placeholder relative to the decimal. So we report this value here as 120 feet with 3 significant figures. We can use scientific notation, express it as 1.20 times 10 to the 2 feet. That's 120 feet, but with 1, 2, 3 significant figures. Now let's look at the multiplication problem. What if we have the same idea that each of these quantities is really plus or minus 1. There's some uncertainty in that last digit. It has to be uncertainty at least of 1. If it was less than 1, think about it. We'd have another value. It would have been 25.0 feet instead of 25 feet. So the way you see these numbers implies the meaning of the number. It implies that it's 25 plus or minus a foot. Now, we're not going to do the statistical arithmetic. You might learn that in a stats class. We're not going to actually do that arithmetic. So we don't want to play around with the arithmetic of these numbers, but we can take the idea that it would be like 24 to 26 times 35 and think about how that's going to change our result here if it were 24 or it were 36 in the extremes of our uncertainty. If it's 24, that would be 840. And if it were 26, it would go all the way to 910. So you see the wavering, the plus minus is occurring in that second placeholder. So we have 2 significant figures that are actually significant in this value here instead of 3 when we added the values up for the circumference. So for the area here, it's actually exemplifying our sig fig rule for multiplication and division in that we count sig figs. We have 2 sig figs times 2 sig figs. The result is only good to the second significant figure. So the 8 is the most significant digit. We're really certain that this value is 800. And then we're also pretty certain that that second digit should also be an 8 once we do our rounding. So this should be 880 square feet. And then that would round to 8.8 times 10 to the 2 square feet. Now notice I don't add that extra 0 because I only want to write 2 digits here to apply 2 significant figures in this result here. So we can use scientific notation to help us write these results once we determine where the value should be rounded using the rules of significant figures. Okay, so I don't necessarily expect that you picked up all the rules here. We'll see them written out and discuss a little bit more in our chapter summary video. But what I hope this problem exemplifies for us is really what the rules of significant figures are meant to imply. They're not changing arithmetic. We're just dealing with the arithmetic of imprecise numbers or of numbers that aren't exact quantities due to them being representative of experimental quantities. So we'll talk more about sig figs in our chapter summary videos, or you can read more about them in chapter 1 in your textbook, and then we'll be discussing them in lecture as well.